Dear students, in this video I explain infinite series. This is this topic is the fourth topic in fourth module. Second topic, infinite series. Okay, so your infinite series means in many of the problems in engineering, infinite series occur frequently. The adequate knowledge on the nature of the series is necessary to solve the such problems, and hence studying the convergence and also divergence of an infinite series is very important. Infinite series means sometime here we need to find the series solution of any problem. Sometime here we know that an exact equation, but here we need to find the series solution of that equation. Then we go to this infinite series. Okay, definition. If un is a function of n defined for all integer value of n and expression of the form u1 plus u2 plus u3 dash 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 un containing infinite number of term is called as infinite series, usually denoted by summation n is equal to 1 to infinity un or summation un, where un is called as the nth term or general term of the infinite series. Okay, the sum of the first nth term of the series is denoted by Sn and is equal to u1 plus u2 plus u3 dash 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 un. Okay, next we come to divergent, convergent, also divergent. Here, a series un is said to be a convergent if limit n tends to infinity, Sn is equal to L. If L is a finite, then where L is a finite. Okay, then A is said to be this series is un is said to be a divergent if limit n tends to infinity, Sn is equal to plus or minus infinity. Suppose this Sn limit n tends to infinity, Sn value finite, then it is a convergent. If we suppose we get infinite value, the infinite value then you called as a divergent series. Example, 1 plus 1 by 2 plus 1 by 4 up to dash 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 1 by 2 to the power of n minus 1. It is goes on continuing up to infinity. So this series, first we write the nth term. Here we use in geometrical series. So here we know the geometrical series in the form of a plus ar square plus ar to the power of n minus 1. Then the sum can be written as a divided by 1 minus r. Okay, then now limit n tends to infinity, Sn, this can be written as limit n tends to infinity, a by 1 minus r means here we take a is equal to 1 and r is equal to 1 by 2. Simplify, here we get 2. 2 is a finite value, therefore it is a convergent series. Next we come to second problem, 1 plus 2 plus 3 dash 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 up to infinity. Suppose here it can be written as n into n plus 1 by 2. Suppose we start from 0, n is equal to 0, we get 0 plus 1 by 2. Okay, it go to 2, take n is equal to 1, 1 plus 1 is 2, 2 become cancel, we get 1, take n is equal to 2 means here 2 plus 1 is 3. 2 cancel, we get 3 like that. Okay, so in generally we can write n into n plus 1 by 2. Now we apply the limit. Suppose we take n is equal to infinity, infinity into something is infinity and infinity by something is also infinity, then the given series is a divergent. Okay, next here, necessary condition for the convergence of a positive term series. If a series of a positive term is a convergent, then limit of its nth term is equal to 0. It means if series is a positive term, it's a positive term of a convergent, then limit n tends to infinity we can written as un is equal can written as 0. Okay, next we come to the nature of the series. Here in nature of the series we divided into two tests. One is D'Alembert ratio test and also another one is Cauchy's root test. First I discuss Cauchy's root test. So Cauchy's root test is state that let un be a series of positive terms such that limit n tends to infinity, un to the power of 1 by n which is equal to L. If L value is less than 1, then series is said to be convergent. If L value is greater than 1, series is said to be divergent, and if L is equal to 1, then test fail. Okay, next here come to some standard result. This is very important for solving the problem. First one is limit n tends to infinity, n to the power of 1 by n which is equal to 1. Limit n tends to infinity, 1 plus 1 by n whole to the power of n is equal to e value nearly 2.7. Next, limit n tends to infinity, 1 plus x by n whole to the power of n, which is equal to e to the power of x. Now come to the problem. Test the convergence of the series summation n by n plus 1 whole square into n square. So now consider this is equal to un. Un value n by n plus 1 into n square. So convergent series state that Cauchy's root test state that limit n tends to infinity un whole to the power of 1 by n is equal to L. So first we have to find un whole to the power of 1 by n. That is un value n by n plus 1 whole to the power of n square. Next un whole to the power of 1 by n. So we take the power 1 by n on both sides. That is n into n plus 1 whole to the power of n square whole to the power of 1 by n. 1 by n, 1 n become cancel. Then we get n by n plus 1 whole to the power of n. But we know that 1 plus 1 by n value e. It is a standard form. That was here this n is goes to denominator. Then it can be written as n by n plus 1. This can be written as this can be written as 1 divided by n plus 1 divided by n. Okay, then whole to the power of n, because 1 to the power of n become n. Then here again this can be written as 1 plus 1 by n. Here it means n is the LCM of both the two terms. Then it become n by n plus 1 by n whole to the power of n. Okay, then n by n become cancel. You get 1 plus 1 by n into whole to the power of n. So then now apply the limit n tends to infinity un whole to the power of 1 by n, which is equal to limit n tends to infinity 1 by 1 plus 1 by n whole to the power of n. So that is 1 by e, that is 1 by 2.7. This value is less than 1. Therefore the given series is convergent. Here we like that we have to check the whether the given series is a convergent or divergent according to Cauchy's root test. Next we come to another problem. Examine the convergence of the series 2 square by 1 square minus 2 by n whole to the power of minus n, 3 cube by 2 cube minus 3 by 2 whole to the power of minus 2 plus 4 to the power of 4 by 3 to the power of 4 minus 4 by 3 whole cube dash dash dash. First we check it is a so first we write using the series. First we write the nth series or nth term. Okay, see 2 3 4 means n plus 1 term na. So this is 1 2 3 means here divided by n. So whole to the power of 2 whole to the power of 3 whole to the power of 4 means whole to the power of n plus 1. So this term can be written as n plus 1 divided by n into n plus 1 minus n plus n divided by n minus 1 minus 2 minus 3. It means whole to the power of minus n. Then take un whole to the power of 1 by n. It means take the power 1 by n on both sides. That is n plus 1 by n whole to the power of n plus 1 minus n plus 1 by n whole to the power of minus n whole to the power of minus 1 by n. Okay, then here we can write, simplify this n and become cancel. Then 1 plus 1 by n whole to the power of n plus n minus again like that same like that minus 1 by n. Here 1 plus n, here again is just split, that is 1 plus 1 by n whole to the power of n into 1 plus 1 by n minus 1 plus 1 by n whole to the power of minus 1. So now in this two term we take here this is take 1 by n value, this value is e, 1 by n, apply the limit now. Okay, this whole term it become e, this value become 1 because 1 by infinity value 0, 0 1 plus 0 value 1 and this value also 1. Therefore e minus 1, 1 by e minus 1 value here minus 1 to the power of minus 1. So you can write 1 by e minus 1, this value is less than 1. So therefore un is a convergent. Okay, next we come to second another problem. Discuss the convergence of the series 1 by 2 plus 2 by 3 whole x, 3 by 4 whole square x square, 4 by 5 whole cube x cube plus dash 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 infinity up to x greater than 0. So first we write the nth term, that is you can written as n plus 1 divided by n plus 2 whole to the power of n into x to the power of n. So now apply 1 by take 1 by n on both sides, that is un whole to the power of 1 by n is equal to n plus 1 divided by n plus 2 whole to the power of n means 1 by n become cancel, x to the power of n whole to the power of 1 by n also cancel, we get x. Now here in numerator take x as n as the common factor, it become 1 plus 1 by n. In denominator take n as the common factor, we get 1 plus 2 by n. n become cancel. Now apply the limit. So 1 by infinity value 0, 1 plus 0 value 1, 1 plus 2 by infinity value 0, 1 plus 0 value 1. Therefore we get x. Here that is condition. If x less than 1, then series is convergent. If x value is greater than 1, then un is a divergent. If x is equal to 1, then the test fail. Like that we have to check whether the given series is convergent or divergent by using Cauchy's root test. Thank you.